I'm Allison, and you are in Beerland. Yeasts are a very important part of the brewing process. Members of the class fungi, there are two main yeast species used in brewing beer. These are Saccharomyces cerevisiae, commonly referred to as ale yeast, and Saccharomyces pastorianus, commonly referred to as lager yeast. You may also see wild yeast strains and bacteria used to ferment beer. While similar in structure, these yeast species have varying optimal temperatures for fermentation and may produce a different range of secondary chemical compounds such as phenols and esters. Yeast reproduce through a process called asexual budding. Maintaining healthy yeast populations is critical to making high-quality beers. Healthy yeast populations are achieved by creating a nutrient-rich and chemically correct wort. This is done by ensuring proper saccharification of the starches in the mash, maintaining proper wort pH, and making sure to add zinc and oxygen. Doing this can go a long way in ensuring yeast health and higher product quality. The process of growing yeast in a laboratory or brewery is called propagation. When operating a yeast propagation program, very strict manufacturing process guidelines should be met. Propagation requires strictly adhering to sterile procedures, as contamination can travel quickly in the high oxygen, high sugar content propagation environment. Gloves should always be worn without exception. Gloves should be sprayed with isopropyl alcohol frequently to sterilize. Gloves should be changed when handling different strains to prevent cross-contamination. Propagation from single colonies is a process that involves streak plating yeast cells from a frozen archive. After the plates are incubated and colonies are present, single colonies are chosen and added to sterile, nutrient-rich broth. From here, growth continues in progressively larger steps until the desired cell concentration is achieved. Oxygen is required to keep the yeast cells propagating and not fermenting. Lack of oxygen will cause propagation to end and fermentation to begin. When a pitchable quantity of yeast is purchased, sanitize the exterior of the package as well as the port on the vessel where the yeast will be added. Add the pitch of yeast to freshly made sterile wort for best product quality. When using a liquid pitch of yeast, it is recommended to oxygenate the wort. When reusing yeast in the brewery, certain conditions should be met. Reuse yeast up to 10 generations from clean, uncontaminated beers. It is not recommended that yeast be reused from beers that have been dry hopped. If possible, try to harvest and reuse yeast before the tank is cold crashed. This keeps the yeast metabolically active and reduces the lag time before fermentation will begin. Remember when reusing yeast to never judge a yeast by its slurry. It is always best to conduct a cell count before reusing yeast. This is done by running off yeast from the bottom of the cone until the consistency looks light, fluffy, and homogeneous. Then collect a sample of yeast. Perform a 1:100 dilution and stain with methylene blue. Count the cell concentration under a microscope using a hemocytometer. Use math to calculate the pitch of yeast needed for the brew. Properly clean and sanitize a safe and appropriate collection container. Harvest yeast into a clean, sanitized, closed vessel. For best results, never store yeast and re-pitch immediately. If strict manufacturing process standards are met, following these steps can save your brewery lots of money. In unsanitary conditions, yeast re-pitching can lead to cross-contamination, unpleasant off flavors, or unwanted house flavors. Maintaining proper brewery hygiene and procedures will go a long way in preventing such issues. I think it's important to keep in mind when we're talking about yeast in the brewery that yeast are living creatures. And like all living creatures, yeast have boundaries. And if we choose to bulldoze through the boundaries of the yeast by harvesting yeast and letting it sit for a long time before repitching, or not providing correct nutrients for it, or maybe our mash pH is off, or maybe we didn't oxygenate the wort, by pushing the boundaries of yeast in this way, we're not doing our products any favors. So it's important to consider yeast as the living creatures that they are, to make a wort that's going to sustain their growth, to harvest and repitch immediately, to acknowledge the limitations that these small single-celled organisms have. They are the ones eating the sugar and turning it into alcohol, and they're the ones doing all the work. I think acknowledging that the yeast are living creatures, acknowledging their boundaries, acknowledging their limits, and respecting those will go a long way in making high quality beers in the brewery.